Hi, we're going to talk about balancing chemical equations. So to show that the law of conservation of matter is occurring, or law of conservation of mass is occurring, we have to balance our chemical equations. We have to show that we have the same amount of stuff on the reactants and the product side. So in a balanced chemical equation, that means that we have to have the same number of each type of atom on both sides of your arrow. Again, this is because matter is always conserved in a chemical reaction. We're going to use coefficients to balance chemical equation. When we balance, we can only add coefficients. We can't change subscripts. We can't change anything else. We can't change formulas. We can only add coefficients. So I've got two examples here, and these are the examples at the top of your balancing chemical equations assignment number 1. All right, here we go. So here's my little pen. So when I balance, I recommend you write like a little cheat sheet out. So I'm going to list all my elements. I have Se, and I have Cl, and I have O. So Se, Cl, and O. And I want the same number of each thing on both sides. So I have 1 Se on my reactant side. I have 6 Cl, and I have 2 O. On my product side, I have 1 Se, 2 O, and 2 Cl. So when I add coefficients, I'm multiplying by everything in front. So my SCs are the same, my O's are the same, so all I'm going to look at is my chlorines. So I have 6 versus 2. What can I multiply by 2 to give me 6? Well, I can multiply by 3. So if I put a 3 here, that equals 6 now. So what I'm going to do is I'm just going to put 1s in all these other spots. You don't have to put the 1s, but I put the 1s as placeholders so that I know that it's balanced. All right, on the second one, I have NHNO. So N, H, and O. I have 1 N, I have 3 H, and I have 2 O. And that's on my reactant side. On my product side, I have 1 N, 1 plus 2, or 1 plus 1 makes 2 O, and I have 2 H. All right, when I have a 3-2 split, where I have 3 on one side and 2 on the other, the only thing I can do is make them the smallest common number, and the smallest common number for this case is going to be 6. So I'm going to multiply this H by 2 to get it to 6. I'm going to multiply this one by 3 to get it to 6, and then we'll figure everything else out in a second. So I have 2 times N, so that gives me 2N, and 2 times 3, which gives me 6H. My O's are staying exactly the same. I haven't added anything to them. On this side, I have 3 times 2 makes 6H. And then I have 3 plus 1 gives me 4O. So now my N's aren't balanced, and neither are my O's. So let's go ahead and try to do my N's first. So I've got 2 N's. And that's now going to give me 2 plus 3 makes 5 O's. What can I multiply by 2 to get me 5? Well, that would be 2.5, but I can't have half an atom. So what I'm going to have to do is put a 5 here and double all my other coefficients. So 5 times 2 makes 10, and I'm going to double all my other coefficients. So this is going to become 4, this is going to become 4, and this is going to become 6. And I'm going to check my work really quick to make sure this is right. So let me change colors. Just kidding, I don't know how to change colors. All right, so 4N, so 4 times 1 gives me 4N, 4 times 3 gives me 12H, and I already did. 5 times 2 gave me 10O. So I have 4N, I have 4 plus 6 makes 10O, and I have 6 times 2, which gives me 12H. Not all of them will be this complicated. This one just happened to be more complicated. So my final answer on this one is going to be 4, 5, 4, 6. Now, I want to make sure I can reduce this to the smallest common numbers. So if I had 8, 10, 8, 12, I could divide all of those by 2. I can't divide these by any number to make them smaller, so that's how I know I have the right answer. There are a ton of videos out there on balancing chemical equations. If you don't understand the way I did it, I'm going to post another video for you in your announcement section of another guy that I really like that does videos on balancing. and you can look at his as well. So if you have any questions, please message me. I'll talk to you guys later. Bye.